So my question is, when the pancreas becomes loaded with iron after that liver is dysfunctional and cannot handle the iron load, why is it that beta cells are preferentially affected to any of the other beta cell types? There are alpha cells, there are beta cells, there are delta cells, there are gamma cells. Why is it that the beta cells are the ones being targeted? So you have to ask yourself, okay, well, we know about they both have a tie to cellular energy, right? Insulin helps the cell use glucose. Iron helps the cell break glucose down. What is it? There's something within probably the beta cells that would make them a designated target for iron overload. What could that be? So let's just read this last point here. Beta cells regulate energy use and thus have a unique tie to other components of proper energy usage, right? So beta cells have some sort of role in iron mobilization, because when glucose comes into the body via our food, insulin is telling the cell, hey, glucose incoming. Mobilize that iron so it can help catalyze the electron transport chain. And so here we go. This is a paper from 2008 talking about how pancreatic beta cells were found to express hepcidin, which is an iron uptake regulatory peptide. Now, prior to this paper, it was believed that hepcidin was only found in the liver. Hepcidin's nickname is the master iron regulator. Okay, we'll talk a little bit more about what hepcidin actually does, but because of its role in iron homeostasis and the liver's role in iron homeostasis, it was thought that hepcidin was reserved just for the liver. Sure enough, they found hepcidin in beta cells, not alpha cells, not delta cells, not gamma cells, just beta cells. Okay, so the master iron regulator, hepcidin, in beta cells and no other cell type in the pancreas. So within this paper, it was found that beta cells are the only pancreatic cell type with hepcidin. And with higher levels of inflammation, whether acute or chronic, the levels of hepcidin are upregulated. So when inflammation is present, cells with hepcidin create more hepcidin. When more hepcidin is created, serum iron levels decrease. Okay, so hepcidin is like a warden. It is what decides whether or not iron goes out of the cell or into the cell. The more hepcidin there is, the more iron stays in the cell. So that's why when there's inflammation and more hepcidin, hepcidin is pulling iron out of the serum into the cell. So therefore, increased hepcidin correlates with the pathophysiology of anemia, right? More hepcidin, less iron in the serum, right? So if you were to go get a blood test for serum ferritin with high levels of inflammation and high levels of hepcidin, your tests are going to come back saying that you have low serum ferritin. And you'd probably get diagnosed with anemia. But the iron itself didn't go anywhere. It's not in the serum, it's just in the cell now. So this increase in inflammation causes a reduction in the serum iron levels, and iron isn't able to leave the cell. Now we start to connect the dots because we know what happens when iron is locked in a cell that does not have the capabilities to manage it. So the liver becomes overloaded with iron. Its storage cells are filled to the brim, and it doesn't have any place else to put it. Iron infiltrates other cells, right? The GI tract, the endocrine system, the excretory system. Iron in cells that do not have the means to manage it becomes very reactive. It causes an inflammatory response. That inflammatory response causes cells with hepcidin to upregulate hepcidin to prevent serum iron from being like gas on the flame, right? Because the body knows how reactive iron is in a state of inflammation. So it upregulates hepcidin, retains all that iron in the cell. Beta cells, having hepcidin, are now retaining more iron than usual. When you retain more iron than usual, you are setting yourself up for more inflammation. That is why beta cells are an inadvertent victim of iron overload, more so than alpha cells, more so than delta and gamma cells, right? That explains why beta cells are specifically targeted in a state of iron overload.